Tree diagram worked example 2. This is a continuation of tree diagram worked example 1, but in this video and example we are going to be covering the law of total probability. So the law of total probability states that the probability of event A is equal to the probability of A intersect with event B plus the probability of A intersect B complement. Now this is if we only have two separate events that can occur. We can either have event A or event B. So the probability of A is the probability of A intersect B plus the probability of A intersect B complement. And how we can also visualize this is that the probability of A intersect B, if we recall from the conditional probability, the probability of A given B is equal to the probability of A intersect B over the probability of B. This means that if we rearrange this equation and make the probability of A intersect B the subject of the formula, we have the probability of A intersect B being equal to the probability of A given B occurs times the probability of B. And if we examine our tree diagram, this probability of A intersect B is the product of the probability of one branch and multiplied by the probability of the next branch in the tree diagram. So for example, if we wanted the probability of rain and it being a sunny day, if we look at this diagram, we want the probability of rain and a sunny day. That is equal to the probability that it rained given that it was sunny multiplied by the probability that it was sunny. And this will be equal to the probability of rain intersect with sunny, because we have seen this already from this formula over here. So the probability of rain and sun is the product of 0.8, which is the probability of it being sunny, multiplied by the probability of rain given sunny, which is 0.3. So this is our answer, and this is 0.24. Now we have calculated the probability of rain and sunny. Well, how about the probability of rain and not sunny, or the probability of rain intersecting with the event that it was the complement of sunny? This is equal to the probability of rain given that we had no sun multiplied by the probability that we had no sun visible or an overcast day. And this is equal to this branch over here, which you can see 0.75. And we're multiplying this by the probability of no sun, which is 0.2. And this is equal to 0.15. So now we have the probability of rain and sunny day equals to 0.24. We also have the probability that it was rainy and intersecting with not sunny, which is equal to the probability of rain and the complement of a sunny day, which is equal to 0.15. And then we want to figure out what is the probability that it was raining. And according to the law of total probability, the probability that it was raining is the probability of rain and sun plus the probability of rain intersecting with the complement of a sunny day, which is equal to 0.24 plus 0.15, which is equal to 0.39.